So how do we check the first derivative test? The first derivative test could tell us if it's a max, like this example here, if it's a min, or if it's inflection, right? So how do we check the first derivative test? First derivative test could tell us if it's a max. This example here, right? So if you look here, what you can see about the gradient here, increasing or decreasing? It decreasing. So we can say that dy dx is less than 0 here. Here we experience something called a decreasing function. Right? What about here? Dy dx is more than 0. So here we experience something called a increasing function. Okay? So if your differential goes from less than to more than, you have a minimum point. If your differential goes from more than to less than, we have a maximum point. By the way, what happens here again? dy dx is 0 here, right? Equal to 0, right? What about here though? You recognize that the function increasing. So here you have dy dx is more than 0. And here you have dy dx is more than 0 as well. So the function increasing. How you will show this on an exam? Adrian? How you will show this? Any ideas now, right? Right, so here what you will do is, all right, really easy. What you will do is, when you work it out, right, and you will know the stationary points. So let's pretend that the stationary point was 2, right? What you have to do is pick a value after 2 and a value before 2. So let's pretend you pick x as 1 and then you pick x as 3, right? All you have to do is take x as 1, drop it in dy dx and see if it's more than. Take x as 3, drop it in dy dx, see if it's more than. And you're good to go. Right? Right, but there's one side problem. Let's write out this one. Dy dx is what? This one. Less than 0. Dy dx is. So if there's a sign change in dy dx, it could be a max or min. If there is no sign change, it's a point of inflection. So I have a small question, right? Note that if we have something like this, let's say our stationary points are x is 0, x is 2, x is 3, and x is 4. Let's say that's it, right? And we want to determine, we would like to determine, Nathan, we want to determine if at this point, there's a point of inflection, right? Narayan said earlier, well, right, if you want to check here, we just pick x as 1, x as 3, and we have a sign here. But these are our stationary points. What values would you choose to determine if this point is max, min, or inflection? What you will choose? You will choose 0 1, but that's very bad. Why? Because these values are stationary points. So if you plug in x as 0, what are you going to get? You're going to get 0. Right? If you plug in x as 0, remember, all of these here are stationary points. Right. So you have to choose values in between here. Right, Keshav? So it's important to kind of slot out your stationary points. Yeah? I know you someone just figure out all these things like in a slide now. Yeah, you don't do it already. You don't do all this already. Right, so here, x is 1, and what you choose here? Anything you want, right? You could choose 2.5. Okay? These are the points, Narayan, that we're using to check in our tests. Are you okay with that? Right? So, question, do we have to do the second derivative test? Or we can just do the first derivative test alone? We can just do the first derivative, right? Right? Make a note of this. So in this, we have to look at rates of change, and we have to take a look at the Q sketch. Make a note of all this quick. Let's do an example. Let's try one now. We ain't doing too much. Let's see if we can get in the first one. Right, determine the nature of the stationary points. Are you go there now? Let's try this one. Let's see if we can find the stationary points here. Find the stationary point and if it's max, if it's min or else. Right, differentiate, make it equal to 0, find a stationary point. And if it's done, you can try quick sketch. Sorry. Right? Yeah, number. Right, try and do a sketch. Anybody have a little small sketch? That's it? No small sketch? It ought to be a perfect sketch. I just want a little small thing. Please remember, when you find the x, you have to find the y as well, right? So step number one, we find f prime x. That's minus 4x cubed minus 6x squared plus 0, right? And then we tell them that stationary points occur when dy dx is 0 or f prime is 0. So you get minus 4x cubed minus 6x squared is 0. Carry it across, do your thing there. How much will I get? X is what? 3. Minus 3 and 2. That's the only answer?
And 0.
And 0. Nice. So your two values are minus 3 and 2 and 0. You have to find your y value as well, right? What's the y value? Well, when it's 0 is 2. What's the y value when it's minus 3 and 2? You have the stationary points, right? So you gotta get down the y value too. What again? For minus 3 and 2. Minus? Minus 9? How much you got? How much? 59 and 16. All right, we'll work with that, right? Everybody else get up? You gotta put your values in here, right? All right, nice. 1, 2, 3, nice. So, how do we determine if it's max or min? Right? But what we're going to do, we just have to lay it out a little bit. Right, where are our stationary points? Our stationary points are here and here. That's okay? So let's check and see who's max and who's min, right? So for x is equal to minus 1.5, I am choosing here and here. Right? I am choosing those 2 points, right? So f prime minus 2, f prime minus 1. What you all got there? F prime minus 1 is what? More than 0 or less than 0? I get more than 0 here, less than 0 here. I'm just making up something. What I got? Plug in the value for me now. Minus 2 was what? This is minus 8, positive 8. That will be positive. What I got? Yeah, feel this one here. Positive. Minus 1 will be minus 6. This one looking like less than 0. What I get this? More than 0 with minus 2. Yeah? So therefore, this point is what? right? It went from more than to less than, so it appears to be a maximum. Right? Get it up? You okay with that? Oh, you have to do the last part first. Well, point. Check and see if this max open or inflection. 0. And do a small sketch. Right, plug it in there. Next one, for x is 0, what you'll choose? For x is 0, what you'll choose? Minus 1 and 1, right? So find f of minus 1, we did that already. And find f of 1. F of 1 looking like minus. So, what this is here earlier? It stayed less than, so what it is? A point of inflection, right? Right, let me do a quick little sketch now. Huh? Yeah. Suppose they are. Right, 0, 2 is somewhere around here. 1, 2. 1, 2. Minus, what is this? What's 59 and 16? Decimal. 3 point something? 3.6, right? Right, question. Do a quick little sketch earlier. Hurry up. Well done, Ring. Hurry up. Right. Hurry up. Will you get through? Start with this sketch now. Right. What kind of point this is here? It's a max, right? And there's a point of inflection where decreasing to decreasing. Let me see you do that quick now. It be perfect. Right, so we know for sure the function decreasing there, sorry, increasing there. The function decreasing here, a little stationary-ish. Something like that. Might look something like that, right? Maximum here, we know that for sure. And then here is a point of inflection. So we have to get a point of inflection here. Right? And that's it. That's okay. We don't really know what's going on outside here because our working was really minus 1, right? So don't go beyond that. Right? But more than likely, there's no other stationary point. So based on what we did, it will continue to go down here and continue to go down. Right? Increasing here, decreasing, continuous. All right? Everybody okay with that? Sure. I will just squeeze in one and I want to do a rate change. Right, Olia, I want you to note something, right? I want you to note that if you find right, if you find f prime of a and it gets 0, right? It means a is a stationary point. Everybody okay with that? So if you do f double prime a and it equals 0, this does not necessarily mean it is a point of inflection. Right? They call this a inner. I know that's something wrong with it. Right? They call this an inconclusive test. Right? So if you do this and then you plug it in double prime and it gets 0, this is not a conclusive test. So you cannot after this say, well, here's what a point of inflection is there. If this happens, Keshav, you have to go back here. Right? If this happens, you have to use the first derivative test. All right? To conclude. Don't forget that, yeah? Oh. Wait, okay, Keshav, I'll take that out. I put Keshav. Yeah. And both of those Keshav? Yeah. Joshua? Yes. Pala in front is Joshua. Yeah, pride and thinking pala in front is Joshua. Like if Joshua come now, he can answer them, right? Watch and see. Are you okay with this? Am I okay with this? Yeah? What would happen if I ask you to sketch, right? But it have more turning points. What you would do? Like suppose there was a minimum here and so on. Let's connect them up, right? What you could do is you could do the turning points and then connect the graph up. So if there's a minimum here and a max here and an inflection here, do that. And then connect them up together. All right? If they ask, right? If they ask to sketch. Nice. Let me just squeeze in one more. Oh, I like this one. You all might not like it, but I like it. Ready? Try and please. Oh, sorry. Right before how you would begin to differentiate it. I don't know. I'll tell you. I think it is a bit like this. Try this quick. Take your time. I want to see the first part, for example, the differential. We can make a little substitution or something. Taking a little substitution. Why are we? Oh yeah, try that quick. Tadi bahasa ini juga perlu kasih. Any ideas to start this up? What we can do here? Take out this square, and put this square on the outside, and then do what? Okay. Alright, but what if we let u equal to what? Try and pass. Make a substitution and see if it will help you. You change rule and work it out. That's different ways to work it out. Right? So why you make a substitution for here? Cos x. So can we find du dx? Where's du dx here? Minus sine x, right? And now y is equal to what? Sine squared u. So we need to find dy du. What's the differential of sine squared u? Lucas. So if you have something like this, what's the differential of that? You can bring down the two, differentiate in the bracket and so on. Yeah, you can do that. What's the next way to work this out? Let w equals sine u, and then what? To sine u cos u. So ideally, for you to differentiate things like this, oh sure. Online classing. Yeah. Ideally, here's what you could use. You all might remember this. You all remember that cos 2x is equal to 1 minus 2 sine squared x. Remember this? So sine squared x is what? Sine squared x is equal to a half minus cos 2x. I remember this? Yeah. So can I replace y with this? Y is equal to half minus a half cos 2u. So I use the decide density and I rearrange it. And I get this? Yeah. Cos 2x identity. Set back class. Remember cos 2x have three identities. Cos 2x is 1 minus 2 sine squared 2. Remember this? Take it back and make sure. So now we can differentiate a little bit easier. What's the differential of a half? 0, right? What's the differential of a half cos 2u? So you write back the minus a half. The differential of 2u is, the differential of cos is what? Minus sine 2u. So you will end up with sine 2u. Okay? So the differential of this is this. You see that? So by chain rule, dy dx is equal to, by chain rule, dy dx is equal to, oh, I write it down there, right? dy du multiplied by du dx. Dy du was what? Sine x, and dy du was sine 2u. So that will be sine x multiplied by sine 2u is sine 2 was u again cos x. That could work. This could work, Olia. If you get confused, tell me. Right? I just substitute back u, right? Are you okay with that? Tell me. Yeah, sorry. Yeah, I write dy du multiply by du dx. Right? dy du, we found it here. Well, I mixed it up, sorry. I'll wait back to front. Huh? What's that? Yeah, no, I just write it u like a y. Yeah. Are you okay with that? So dy du by du. There's pure math, sir. Yep. You take a say go. But I finish it. Oh, you mean DSB thing? Come on this side, but I'm telling you before lunchtime. Come on this side. Right, sorry, yeah. Ali, what a sign? All right, yes, minus sign. Right, but I wanted to check something as well, right? For those who did it like this, right? You bring down the power, you differentiate sine, you get cos u, you write back sine u. Correct? Some people did it like this. You recognize what this is? Watch it good. 2 sine u cos u. And that's sine 2u. Yeah, so I wanted to show you that it can work as well, right? Right, so that was sine 2u. I drop in u. I just feel like my u was cos 2x multiplied by that. Right, nice. Now, what's the next part? Find the stationary, right? So we know that stationary points occur when dy dx is 0. So I'm going to make minus sine x sine 2 cos x equal to 0. That's okay? How do I solve something like this? Just start going. I have a product and it equal to 0. How do I begin to solve something like that? Very good. So you can say minus sine x is 0 or sine 2 cos x is 0. Right? If I solve this, what will I get? And I have a general solution, something. What would I get here? Of course, the minus will cancel. You'll get sine x is 0. You'll get x is sine inverse 0. General solution is what for this?
And 5 plus
By 0. Sorry, the mark. In that case, it's 0. Everybody okay with that? Copy it down. See if we can finish this last part here. Come on. Okay, all right, right? Right, you all done? All right, we're waiting on. Someone, hurry up, we have the last part to prove. Right, we already proved the n pi for all. Oh my, right, we already proved the first part. Oh yeah, try the second part from her. Everybody guys already? Right, check the second part from right, okay, sharp, the next one. Help me out here. Quick. No, you. Can forget your last name. Help me out here. How we solving something like this is a trace. Until you move across sign, and sign inverse 0 is what? 0, right? So when they move across 2, you'll get 0 as well. So you're going to get x is equal to cos inverse 0. The one general solution, right? What's the general solution for cos? 2 and 5 plus and minus alpha. And alpha is what? What is alpha? Well, okay, yeah, well, it comes from this, right? So you end up with 2 and 5 plus and minus what? Pi on 2, you all said? Pi on 2.
So like now first, just like this. First, come like this.
This is a possible 2019.
Oh, that's possible.
Right? Every now and again they'll pop in something like that. But I don't want to get watch. What was hard here? And by the time it's serious, you know, you gotta use some chain rule. Right? When you reach here now and you differentiate it, you know dy dx is 0. The only way you can solve a product is 0 is One is 0, next is 0. Right? And if you look at the solution, if you look at what they are saying here, hopefully general solution come in your mind. You see, tricks can out there in your mind now, but when you're ready for exam, you will shift happen. And you will see that in the general solution there, right? All right, yes, but this was one of the harder ones, right? Why general solution there? Look at the answer. You have to identify that the general solution. That's right. But you probably can't then. You don't solution. Are you okay with that? Yeah? Yeah, not sure. You gotta be okay with it. Right now, right? All right. So after this, we want to do one question on rates of change, right? Right, but do you all remember the principles of rates of change? Right, we need to remember rates of change. How do you know a rates of change question now, right? Right, you see the word rate, right? So if you say rate of change of y, how do you begin to solve something like that? Rate of change of y, how do I write that? dy dt, right? And in order to find dy dt, we write dy here, we write dt here, and we write some other variable here, right? Normally what? X, right? So we need to get dx dt, the rate of change of x, and we need to get how y changes with respect to x. That's okay? If I ask for rate of change of volume, then we have dv here, we have dt here, and if you have volume, more than likely you have what? Probably radius. Yeah? So you need to get dv, dr, dt. So in short, well, whenever you have questions like this, you have to apply chain rule. Are you okay with that? Nathan? Right. Somebody go and try once more now. J Sharp. You want Nathan coming on the board? Go look up and here. Alright, copy down. I want to give you one. Right? And that's basically differentiation. These little things here. Right? Remember the reason I didn't focus on curve sketching. I showed you curve sketching using transformation. Alright? Instead of having to go and do all the differentiation and finding a simple thing. But I'll still do a couple of examples later on. Let's try one research change now. Any questions online? Let's just try one. Right, for those who studying for mock exam, remember you have to come here during the week, right? Monday, Wednesday, Friday. See? Or what way is sit down? Sit down right next to him. Let's sit down right next to him. Joshua. So what's up, what? Ready? Two the figure. Right, moving on that way. Press one all good. Ethan all okay? Come on, press. Something happened, I wasn't press. Oh, you all press, I'm going to press. Right, copy this down. Let's try this rate of change. Very easy. How you find volume again? Of a sphere? 4/3. Very good. Hurry up. Let's try that quickly. Oh yeah, copy that graph. Well done. Right, I don't know yet today, so we figure start physics one time. I don't know anyone who's complaining. Anyway, fine. Let's leave it up. But you have to define the weight of it, feet and volume. Sorry. Go next one. Yes. Well done. 1 minute again, no problem. Right, obviously you recognize that you need to find rate of increase of volume, right? So dV dt. Suppose it said decrease, what has to include in the formula? A negative sign, right? dV dt is equal to dV dr by dr dt. Right, Sabira? Finish already? I'm very distracted here. Apply is good. You know how. Physics 2, yeah. Right, dRdt is what? 0.1, right? Right, we need to get what? dVdr? Alright, what you got with dVdr? 4 pi r squared, and then you plug in r squared, right? When earlier, pure math Monday. So for us, stay longer next week and just I will trust only first. Okay, what's wrong? Right? Remember, they could also come training day in a way to school Monday, Wednesday, Friday. Right? As we hold this thing, that's not the make sure things that we get someone. I was doing more yet get and we'll get some questions.
No, I didn't know where it was going.
Yeah, we will. We will get questions. I don't want in between.
It's getting special, attention.
No, you got, you, a particular keep it. Start for it, and we'll put questions. Right? You can look on the GPT Explore and you get the questions. But the one I just do is, I'll send it like. No, I pay for chat, but I think the other people is for. Right, PVDR is what? PVDR is 100 pi by 0.1. Right, I got 10 pi as the answer.
Yeah.
Centimeter squared.
Yeah.
Sorry, centimeter cube per second, right? In a lesser unit, right? Centimeter cube per second. Because it's volume per second. Right? Online, any questions? Alice, are you okay there? Chloe, you going online? You paying attention, Chloe? Alice, I'll put this up in attention. Who? Right, let's do get squeezed in one more now. One that is coming forward, one that comes forward. Okay, before this, back something already. This year, yes, you take the building like this. Try this fast, 30 seconds. You only have 9 minutes to without. Hurry up, move fast. Oh, quick.
Yes, I see.
What is that there? 37 is what? Oh, shot is integration. Alright, that's integration. So. 31. What's that? Sorry? Sure? Somebody said B. Not looking wrong. D as in dog. What do you mind? That's not come from.
Yes.
A, or the class say everything, eh? Pick one and stick to one. What is right? How much book it all come up? No, now working. Now working out in the head to do it properly. How was it E?
Because
it is not E. That work it out fast. You cut up rules. Yeah, but you get wrong. On the say A, B, and
So when I did this question, that's the
yes, you cut up real fast, yeah.
Yeah, B. Because if the tree multiplied process.
And work it out. No.
Wait, no. It's C. No, it's D. It's C. It's D because I minus.
How you getting a minus sign?
The sign, it's just cos X.
Right, so it's x cubed by cos x plus 3x squared by sin x. So the answer is C. Of course, every single letter. Right, so the answer is C. Oh, you have 32. You got fast? So few. Once you get so few. Work out 32. Oh, then work out it thing now.
Sim, ora é você não sabe a bola. É mais uma só moção de salvar a bola.
One second. Nathan, you fucking up it up? Right, so we have all we have to do is figure out the first differential. Right, for the first differential, I got 20 by 1 minus 2x. And when you plug in that, I got minus 20. What again, boy? So I got minus 20 by 1. Yeah, boy? Alright, we'll stop there. Right? Next day we do integration and integration and first order differential. Was that one?